Greetings everyone. We are presenting our mini project titled as Student Course Registration System for the course Objective Object-Oriented Programming guided by Madam Zuraiha binti Ngaden. This project was developed using Java and applies the key Object-Oriented Programming OOP principles such as encapsulation, inheritance, and polymorphism. The main purpose of our system is allow students to register for courses, view their registered course, and ensure that the system can handle invalid operation gracefully. For example, when students exceed the maximum allowed course limit. So for slide 2, the objective of our project is to strengthen our understanding of OOP concept and apply them to build a real-world IT solution. Specifically, the system aims to apply encapsulation by grouping attribute method inside classes like course and student. So for second, apply inheritance by creating subclasses for undergraduate and postgraduate students. For third, apply polymorphism by allowing these subclasses to override and specialize method differentially. Fourth, utilize array list for dynamic storage of registered course. 5 is implement exception handling to handle errors, especially for error course limit. This system helps simulate a real college registration scenario while maintaining structured, reusable, and organized code. So for slide 3, the challenges given to develop student course registration form is in Java that allows user to add course to a student list, remove existing courses, display all registered courses, and to handle any invalid action such as registering for too many courses. We also had to include UML use case and UML class diagrams, screenshots, and the complete source code to show how OOP principle and application from design to implementation. Essentially, the challenges was to make the system both functional and object-oriented, just like a professional application.
For slide 4, thank you, Service. Now we can see slide 4, implementation requirements. The system is divided into 5 main Java files, each with clear purpose. The first one is course.java. This class defines three private attributes: course code, course name, and credit hours. It also includes a constructor and getter methods demonstrating encapsulation, meaning the data is protected and can only be accessed through specific method. For the second is student.java. This is the parent class for all student type. It stores student ID, name, and array list or registered course. It also includes three main methods. So the first one is add course. Course C adds a new course to the array list. And second one is remove course. Example string course code. It remove a course by its code. And the last one is display course. It display all registered course for the student. This structure demonstrates abstraction and encapsulation, keeping course management inside the student class. For the third 5 main Java file is undergraduate student.java and postgraduate student.java. These two classes inherit from student. Undergraduate students are limited to 5 courses and postgraduate students are limited to 3 courses. In the add course method, this subclass override the behavior to include course limit checking. If a student tries to exceed the limit, a custom expectation is thrown. This is where polymorphism is applied since each subclass handle adding courses differently. For the fourth, course limit exceed expectation Java. This custom expectation exceed the built-in expectation class. It display an information message like course limit exceedation. You cannot register for more courses. This demonstration expectation handling preventing the program from crashing and instead guiding the user. For the last is main.java. This is the heart of the program. It contains the main method where objects are create and test. For example, we use scanner, right, to accept user input, create a new course and student object, and call function like add course or display course. Through this, user can simulate registering and dropping course in real time. For the slide 5, you can see UML diagrams. The UML use case diagram show how the student interact with the system, registering, removing, and viewing course. The actor in the diagram is a student and system processing and represent as a use cases. The UML class diagram show the relationship between all classes. The student class is the superclass. The undergraduate student and postgraduate student inherit from it. Courses is used by student and as an association since each student has a list of courses. The diagram clearly demonstrates the hierarchical structure and reusability of our design, a key advantage of OOP.
Nah, um, for system functionality in action, let's look how the system work in practice. When the user run the program, they create a new student object and course object. They're using a method like add course. Student can register for new courses. When when remove course method is called, it search the array list for the course code and remove it. Finally, the display course print out all the register course with their detail. For example, student might register for OOP and data structure if they add a six course as a undergraduate. The course as an undergraduate, the program immediately trigger our custom exception. Hmm, for handling cost limit exception, the cost limit exception exceeded exception is one of the most important part of our project. Without it, the system might continue adding 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 courses endlessly and breaking the logic. By using trash try catch block, we can handle error safely. Uh, if you look at the code using a try catch block, this will ensure the program to continue running smoothly and the user receive a clear and friendly message instead of crash. This approach teaches us a graceful error handling and a critical part of our professional software development. For for flight for source code overview, uh, the source code of our student course registration is organized into multiple Java classes, each handling a specific part of the system. This modular design follows the principle of separation of concern, making the program easier to understand and maintain. Look, the first one is the course Java. This class defines a blueprint for a course, and it includes a three private attribute, which is a course code, course name, and credit hour. This class contrasts to initialize this attribute and getter method to access them. Demonstrating a encryption since the data kept private and accessible through the public method. If you look at the code, this class acted as a data model, used the student class to create and manage course object. For the second student Java, the student class is the best or parents class in our system. It contains attribute for student ID, name, register, course, and register cost is an error list cost that store all the register cost dynamically. This class included method to manage these courses. If we look at the code, this method demonstrate abstraction and abstraction, which is the student doesn't need to know how the codes are stored, just how to use the code. For the third undergraduate student Java and postgraduate student Java, these two classes inherit for student showing the inheritance in action. They both override the add cost method to include cost limit validation. For example, in undergraduate student.java, code you can see there's three courses which is demonstrate polymorphism since both subclasses use the same method name which is used add courses method but behave differently based on the student type. For the fourth course limit exception.java, this custom exception handled invalid course prediction is extend the Java build abstraction and include a custom message. If you look at the code, um, these these system are more friendly, is user friendly to prevent crashes, and give a clear feedback such like course limit exceeded and cannot register for more courses. It uses abstraction to improve system reliability and demonstrate abstraction handling in your OP. For the last one, the main Java, um, e- to the main class that bring everything together is served as an entry point where all objects are created and tested. The program flow work like create a sample courses, create a student object, register courses and handling exception and display the result. This file demonstrate all the classes interact together forming a complete and functional OOP system.
Discussion, reflection, and conclusion. This project gave us hand-on experience applying OOP concept to the real-world problems. Inheritance help us to reuse and extend common student behaviors. Release simplified dynamic cost storage and management. Exception handling, improve program reliability and user experience. We also learned that the importance of validating inputs, checking duplicates, and structuring our code for scalability. In conclusion, our student course registration system successfully meet all project requirements and showcase a strong understanding and object-oriented programming in Java. Thank you.